Welcome to What I Wish I Knew About Concrete Construction conference call. My name is Corey, and I'll be your operator for today's call. At this time, all participants are in a listen-only mode. Later, we will conduct a question-and-answer session. Please note that this conference is being recorded. I will now turn the call over to Oscar Anamate. Oscar, you may begin.
Yes, good afternoon, everyone. My name is Oscar Antomate. I'm the senior concrete engineer in Kiewit, and the topic I'm going to talk today is about concrete construction. I decided to name it What I Wish I Knew About Concrete Construction, thinking about, as I get to learn a lot of these experiences and work on them, you start thinking, what I wish I knew about it, right, before I got to start working with them. So thinking about it, and as you recall, maybe reading in the abstract for the presentation, one of the main things is obviously how we go from theory to practice, right? How we get everything that we know and make it possible in the field, right? How we consider, all the theories and all the best practices and guidelines that different entities like ACI put together, and then take that into the construction in the field, right? And obviously thinking about that, right, how do we even put all those experiences and lessons learned into design, right? So we don't have to really, deal with things that do not, serve the purpose or do not fit the needs, right? So think about that as you see a lot of the slides and you hear me discussing some of the things about concrete and construction here. The main outline for all those of you that are in the phone call, it's mainly, go through the basics, right? Go through the basics of the materials, of the production and delivery aspects, placing and consolidation, protection and curing, and then kind of summing up everything into what I call lessons learned, and it's, kind of key items that you need to keep in mind, and then I'll give you a summary at the end of what I believe are the main takeaways of my 15 years in the industry. So starting with the introduction, obviously for me, the main and the most important aspect about any project is obviously the client, right? Ensuring that we meet the client and exceed the client expectations. Now think about that, right? Many years ago, everybody will be thinking about strength or slump, but as you get to see more complex and sophisticated, mega projects, you start really seeing other type of hot buttons in the clients. A lot of them really are looking for low permeability, right, and low shrinkage and low heat, and all those things related to durability of concrete, right? And what does that mean? That means a lot to you on the planning for your operation. That means a lot on how you're going to take the look at the mixes and maybe optimize the mixes, or how you're going to look at the testing and inspection plan, and you're going to implement a different plan for that, right? And a lot of the work that we do in Kiewit, for example, is massive in size, and we do a lot of thermal control planning. So what type of cooling efforts you're going to implement in the project? Think about production. Think about how you relate all your efforts in the field to that concrete producer, right? We're going to achieve a production consistency, or we're going to need to add some additional supervision, coordination, and quality control efforts. And a lot of it, that many of you and we are seeing today is all about performance. It's all about, high performance projects, high quality. So implementing, the best we can on enforcing construction tolerances that are tighter than what you're used to, right? So the other thing that I've seen recently is obviously looking at the cracking and repairs. There's some owners that really don't believe that cracking or repairs are acceptable. So we need to understand those things when we move into a project, and obviously, make sure that we plan for that in our bid and our construction process to make sure that we avoid those at most. And then obviously the appearance is something so subjective, but then it's always shows up in different architectural concrete projects, right? You need to understand, what does that mean? Do I need to make a mock-up? Do I need to work on a certain material, consistency, so I don't change my different sources of materials, so I don't affect the color of the concrete, right? And many of you that are in the building construction, you're very aware of these requirements when you get into architectural concrete. Now the other thing is about the reality of the specs, right? There's a truth about the specs, and it's so basic. The truth is that there's different ways of looking at the project, right? There's different approach. You have an architect, an engineer, a client that owns the project, the contractor, the producer. But one of the most challenging aspects about the specifications is, who really write the specs, right? The person writing the specs, do they really understand what does that mean to the concrete producer? What does that mean to the contractor? Are they realistic? Are they really, something that you can easily enforce in the local market, right? So how all of the above align really to get the right product? Are we really understanding the specs? Is the client really understanding the challenges, for the operations and for the concrete producer when they write the specs, right? So all of those things are things that are important to know as you get involved in the construction projects, right? And then, something that obviously, not too many people talk about, but then as we support the construction operations, how do we understand really and know what is the mindset of the contractor, right? It's obviously in every project safety first, and that's obviously the most important thing to consider when you're building work. But then there's other aspects and how they're thinking about the projects when they're approaching and bidding and estimating projects, right? They're pursuing projects that they want to win, obviously, so they need to obviously consider, some information from past projects, right? And then once they get into that, they obviously start planning and knowing how they're going to be prepared for that construction process and how they're going to staff it and how the different resources are going to be allocated to supervise, control, and operate the construction process. And then once we are in the field operating, then what does that mean from a compliance perspective? Are we really verifying that we meet the project expectations and requirements? Is that something? How does that look in the whole construction process, and what are the different levels of communication that you need to implement to make sure that everything that you build is meeting the spec and the client expectations? And then I think one of the most important things, in the roles of many of us that are supporting the construction operations in the field is continuous improvement, making sure that we learn what we did right, what we did wrong, and then how we can really benefit from not doing what we obviously don't want to do because we know that is not right, but obviously learning of how to do it right and making sure that that's important too in the process. And obviously we're talking about concrete, and sometimes you get to work in projects and people do not really think too much about what are the concrete properties and how are those concrete properties really going to play a role in the construction process, right? So for me, the most relevant factors, and these are key factors that you can go all across the board and you can find that they're relevant to construction projects. First is strength. Make sure that you obviously have a certain strength, right, that meet the specs that is going to be adequate for your construction operation in your form removal and the sequence. Durability, right, long-term durability. That's I think, like I mentioned before, in the client eyes, in the expectations, durability may be the top of the list of that client, right? And there's many bridges and long-term, 100-year service life plus structures that obviously durability drives the mixed design, and then strength become a secondary thing, right? Workability. Workability is as simple as, what workability means to you, right? It's not about necessarily the slump, right? You cannot just say a slump, it's workability, right? There's a lot of discussion about that in the industry standards that, slump doesn't mean workability, but then what does it mean to you? Is it something that you're going to place by conveying, or you're going to pump, or you're going to crane and bucket, or this is a slip form, right? You need to understand what are the operations you're going to implement in the field, and then what are the mix requirements to get that workability that you need. And something that is important, and something that not too many people talk about, but we as contractors obviously are concerned, are the economics. And I'm going to talk a little bit about economics in a couple of minutes here. But then what does that mean? Does that mean really getting the lowest cost mix? Is that really the most economical option? Or are you going to look a little further and then make a better decision? And I don't want to say everything I'm going to say in a couple of minutes here, but think about it, right? What are the economics of a concrete mix? Where is the money? Where is the money in your operations? So thinking about that, right? Then we start thinking about, okay, let's dissect these in pieces and start by looking at the materials themselves. So we're going to talk now about materials. And like I said, select the right concrete mix. What does that mean to you? What does that mean to the project, right? What does that mean to the experience that the field operations have associated to using different mixes? And then, like I talk about the economics, this is a very important thing. We're talking among contractors, right? And this is something that I communicate to our Kiwik people all the time. Think about this. Is the cheapest, lowest price mix design that meets the specs the right choice for the project? Or really, the right choice is to select the mix design that meets the specs but also facilitate the construction process? Why do I say that? Because think about it. You may have the cheapest mix, but then that cheap mix, the lowest cost mix that was provided by a concrete producer, is a high shrink mix, right? Or does not pump well, or you cannot finish it on time, right? Or it's just struggling to vibrate and respond to vibration, right? Is that really the lowest cost to you? Is that the most economical option? And remember, I'm telling you this from a contractor organization. Think about it. It's not necessarily about the price, right? The cost to a contractor is more than just the price of a mix. It's the field, right? It's how long you expose your labor to safety incidents, right? Or how much you spend in the field, right? And how much you have to go and do rework, right? That's the cost. That's really true cost. Sometimes it's not that easily, understand it, but it's something that you need to consider. And then talking about concrete materials, you have to bring the discussion about durability, right? And this may be on the infrastructure side, something that we look at more than in the building construction, given the exposure, right? That you're getting, for example, bridges and pavements compares to a building. But think about it, right? There has to be a long-term performance to that concrete, and there's some expectations about it. And the first thing that you need to ensure is that obviously the concrete properties are met. That's a basic thing, right? You need to make sure that those concrete properties that you are looking for, that you're targeting for your operation are met. Make it strong, make it durable, make it workable, economical. All of those things have to be considered, right? Then avoid degradation mechanisms. And here we're talking about degradation mechanisms as, the freeze-thawing issues, right? Or the corrosion of the rebar, or the scaling of the surfaces, right? We're talking about things that are going to affect that concrete performance in service, that are going to create, distress in the concrete, cause cracking with time, right? And are not going to allow the material to perform, right in the long term, right? Then obviously, something that we looked a lot, because it's something that is evaluated a lot when you're talking about durability long term, is obviously providing resistance to avoid, chloride-induced corrosion, right? We know that we're dealing with reinforced concrete, and that we need to consider what are the strategies to protect the concrete for that, right? You need to look at the mix. You need to look at the surface treatments. You need to look at the cover of your rebar. You need to look at the type of rebar you're selecting to use, right? And there's a lot of different, approaches to this, but to achieve durability, it's a little more than just concrete, right? You need to consider a lot of it, and you need to plan ahead of time, because if you have a project that you need to start and you need to complete in a certain time, a lot of these tests can take 3 months sometimes, and the amount of money you have to spend in consultants and testing programs is something that it's evolving, and it's getting more expensive every time with the requirements for longer durability periods. The other thing is that we as contractors, sometimes we don't care too much about things that are very important. Many people just think that cylinders are cylinders, right? And they're just cause you have the lowest guy in your operation, and you assign him to talking to the lab, and the guy doesn't know anything about concrete. He may know a little bit, and then you just say, hey, yeah, take some cylinders and put them there, right? And those cylinders that you said that put them there, right, now are exposed to a lot of things, right? The solar radiation, you're exposed to vibration in the field. Then people go and handle them at early age, and then they manage them. Some people may go and ride on top of them, do not put a cap on top to avoid having heavy operation, or just put it in the wrong curing conditions. And then what does that mean? What does that mean to us as a concrete contractor? It's not the little cost that you said that it was going to be by just allowing a testing lab to take some cylinders and put a young guy to make sure that they get the cylinders. You know what is the cost? The cost is when those cylinders don't give you the right results. And now everybody's going to get excited in the project, and your engineer record is going to start requiring you now to core your structures, right? And everybody, even the client, is going to start questioning the quality of that concrete in the structure, right? Those are the costs. That can result in stopping an operation for weeks. That can result in investigations that are not planned that are going to cost you a lot of money. So make sure that you obviously provide the right tools for those cylinders to be handled and cured properly so you can receive the right strength. And like I said, what workability means to you. Workability is something that we as contractors are always very concerned about because we need to place this concrete, right? It doesn't matter how much we know about concrete. If you cannot place it, there's no way to really get the job done correctly, right? So here you have on the left side very difficult mixes, right? Mixes that are very rocky. And on the right side, you have mixes that you can see they're working well, they've been pumped, they've been finished well. And I'm not going to get into the story about the one on the left side bottom, but that was a mix that you see that it's just a bunch of rocks. That mix was required to be pumped in one of our projects, right? And we have challenges with the owner, with the client, because they believe that mix met the guidance and standard practice, documented in ACI documents and their specs. But really, when you look at the mix, there's no way to get that mix pumped, right? There's no way to really even vibrate that mix and achieve a good product. So think about it, right? So with that in mind, I'm going to be giving you some examples here of true projects, things that I have been part of it, before Kiewit, after Kiewit, and how, things we have learned in the process, right? And how you can avoid those things in the future. So this one is, it's related to a mega project. This was before I was involved in Kiewit. This is not a Kiewit project. But when I was a consultant, I got involved in this long, claim and litigation process. And this was related to an issue with workability. Early stiffening, was the first item associated to the issues. And here you can see that even when they try to really consolidate the concrete, and you can see even sign of vibration, where you can see even the mortar in those areas where it was vibrated, the concrete didn't want to move. So some evidence of early stiffening. And there, something that was found by the client itself, when they investigated that at the time, was that the source of fly ash was not really adequate. They were having issues with the source of fly ash that was flashing, that was creating the material to stiffen up pretty quickly, beyond anything that you can expect. And basically, that required a change of a source of fly ash. Now that took, it took several, weeks and months to really achieve that, and obviously it affects the contractor. But those are things that can happen to you. So what does that mean to you, right? As you're getting to start working with a project, right? Does that mean that you need to do some tests and you need to do some trials and mock-ups? Think about it. The other thing associated to this project was the workability, poor workability issue. As you can see here, this is an area of concrete where even, you have mortar in some areas and you have areas that have rock pockets, right? You can see that it's not really well lubricated mix. There's an issue with not having the right lubrication. And when I talk about lubrication, think about lubrication from the material itself, right? So what is the material's lubrication? You start talking first. The water lubricates your paste, right? The paste lubricates your mortar, and then your mortar lubricates your concrete, right? That's the basics of lubrication of the concrete, and that's what's going to affect your workability. So this is a chart that we created at the time that we were looking at what had been done in that project, and you can see in the kind of center of that figure that the mortar content was being reduced with time. So this client, was working, trying to avoid workability issues, but interestingly, instead of really improving lubrication, we don't know what was the reason behind it, but obviously they were reducing the mortar with time. Now, you start thinking about what I told you a few minutes ago. Is that really the way to improve workability, reducing the mortar? If you don't have mortar, what happens? You don't have good lubrication. So is that really the right way? Well, then the answer is easy. No, right? You need to make sure that you have the right amount of mortar, right, for your application, that you can vibrate and consolidate your concrete properly. Moving to talk a little bit here about production and delivery. Some some of the things that I always, get involved in my role is obviously looking at optimization opportunities, right? And the first thing that we go and take a look at is batch plants, right? And in this case, this is a batch plant we set up in one of our projects. It's in a tropical area where you have obviously a lot of sun, a lot of wind, and you're gonna have to deal with some hot weather conditions in production. Now, think about some things I'm pointing out here. This is not very common in commercial plants, but this is something that is pretty simple and basic that you can think about in your future operations, right? I'm pointing out here several things. The first one. Well, the first one is you want to make sure you have an area for QC, right? You want to make sure that you are capable of evaluating the material properties every so often and check on your aggregate gradations and check on your slumps and airs and check that you can cast some cylinders and put them in a curing bath, right, while you're producing concrete. But there's some other interesting things here, right? You see that cover beams, and I bet you there's very limited amount of people that have seen that in actual production in the industry in commercial batch plants, right? That's very not common to see, and the reason why we did that is because in this location we have a lot of rain. Every afternoon we get rain from the condensation of the materials of the environment, and then water comes down around 2, 3 almost every day. So we wanted to maintain consistency in our production, so allowing us to cover the bins will provide us better ways to control the moisture in the aggregates that we're using for production of concrete. The other thing that you can see here is cover stockpiles. Now with the type of aggregates we're dealing with here, this is a very challenging thing because they tend to absorb a lot of water in this area of the world, and we had to really protect that from evaporation. So we had sprinklers inside of the stock in the areas covered by the stockpiles. And then we wanted to avoid having a lot of evaporation from the material, and we also wanted to avoid having direct contact with solar radiation, so that way we can mitigate a lot of the temperature, coming from the aggregates. The other thing that is something that you may not see in many locations is having a pave area to manage the stockpiles. The pave area is going to allow you to have a cleaner type of operation managing your stockpile and handling your stockpiles, and then you're going to avoid having a lot of the material coming from the soils when you have a lot of mud in the area, mixed with the aggregates. So those are easy ways that you can optimize your production without having to really spend, too much money. The other thing, to consider is that delivery is not always that simple, right? In our projects, we do a lot of bridges and mega projects, and sometimes it's not that easy, right? You need to consider, you may have to barge your trucks. You may have to really go and pump it several times, horizontally, and then you have to pump it vertically, and that's going to induce different challenges to the behavior and performance of the mix, right? So you need to make sure that you understand the demands of construction for that. And thinking about it, this was interesting. This was a case where we had a precast facility where we are building our own precast yard, and we had set up a batch plant too. And in precast, obviously, you would not consider extending the workability of the concrete, but in this case, we needed to achieve a very high early age strength, and the mix was so difficult that in 10-15 minutes, you were losing the mix. You were getting the mix really stiff, and then it was getting really difficult to vibrate and consolidate, and was creating bog holes. So what we did was very simple, without affecting setting or strength gain of the mix. We used an admixture that could allow, a better retaining of workability, and then that allowed the material to behave better in delivery. And it provided us, I would say, 15 minutes of additional workability, which was great because it allowed us to then build a precast, sequence. And then something that is very common that you see, and many of you should be familiar with this, is withholding water in concrete production and trimming water. And those terms sometimes are used, in different ways, but they mean the same, right? They mean basically they're avoiding putting all the water in the batch, right? They're avoiding to put all the water in the batch. So what happens when you have that issue, right? What happens now is that you are inducing, or the concrete producer is inducing, a more rapid slump loss in your concrete. And obviously that can accentuate with different properties of the materials, and that can accentuate with the temperature of the concrete and with the environment too. In this case, we had a case where the concrete producer was trimming, if you see here, basically 4 gallons per cubic yard. Now, 4 gallons per cubic yard, may not sound like a lot to many people, but that's a lot of water being trimmed by any concrete producer in a high performance mix. So what you see there in the photo is evidence of the issue that we were having. Basically, because of the low water content that mix was coming from the batch plant. Now this mix was not even coming out of the shovel. It was sticky, right? It was sticky. It was not even falling off the shovel, right? So those are things that are simple to modify, right? If the concrete producer have the right controls in place to monitor moisture contents of the aggregates, and they are on top of it, make sure that they have the right numbers and they have things under calibration, there should not be any reason to go to those excessive numbers of trim water. So talking about that, I'm going to talk to you now about a project that I was also involved, before Kiewit, and in this one we're dealing with some concrete producers, in production of high performance concrete, and they have some issues with the production of concrete. In this case, we're dealing with large girders. These are large and long girders. Here you have just a section of the girders, but these girders, basically the client rejected about 65 girders. And basically, at that time they needed help, and that's what, we went there to do. So in that case, you see that the main issues they were having is a lot of bug holes, a lot of bug holes in the bottoms of those girders. Obviously you can think about, well, were they vibrating things well and all that? Sure, the contractor at that time was doing all the efforts that he could with that mix, but then the mix was not still responding well to that vibration effort, right? You still could see how, the mix was, to some extent very sticky, right? You can see that in those surface areas that the mix shows up as a big bug hole, but that you can call it something else, because it's bigger than just a bug hole. But you can see the challenges that they were having there with the finished surface. And some of the things that were obviously observed as we start getting involved is obviously there's some issues with the material mixing, right? With the sequence of the mixing of process. This is a dry batch, and this is a high silica fume content mix, and high performance mix. And you could see how they were having some issues with getting some volume. So they were not even, the concrete producer at that time was not experienced enough to really understand all the challenges of high performance concrete. So they were not even doing a smaller batches. That was also causing some trouble, obviously, in the efforts of mixing. So we obviously helped them, revise that and make sure that they were having the right mixing sequence and things and the size of the batch. But something else that showed up as we were evaluating the concrete was we start getting chunks out of the truck. And look at the size of these chunks of concrete, right? These are chunks of concrete that have built up in the truck mixer blades, right? And this is something mainly that is just poor, obviously, cleaning of the drums, but it's also poor understanding of what high performance makes to a concrete producer, right? When you have a high-performance concrete is going to be much more difficult to clean out of the blades when you compare that to a bread and butter 4,000, 3,000 psi mix, right? The different materials that are involved, right? You have your silica fume in this case and low water cement ratio. Those are going to build up more than just a mix that doesn't have any of that. That is just high water cement ratio and do not have any of those fine materials that can create a lot of stickiness to the mix. So we counted, one of the chunks that we saw, we counted about 15 layers of different concrete. So you can imagine for how long this build-up have continued to occur, and then obviously this concrete producer did not have the right processes in place to clean the blades, right? And that was also causing poor mixing of the mix. So it wasn't not only not having the right sequence, the right size of the batch, but they were also needing some help cleaning up those truck mixer blades because they were needing that for achieving the right product. So let's talk about placing and consolidation. And in placing and consolidation, we're basically going to be talking about, vibration and forms and rebar, right? Those are the main things I'm going to concentrate my talk here. The main thing, with the form surfaces is understanding well what are the different challenges associated to different forms, and what are those requirements by the owner too, right? In some cases you have architectural finishes, and they, may require it to be, without voids and without any surface, imperfection and very minimum amount of voids. In some cases, you saw us as a contractor that do not do our job preparing the surfaces that are going to receive concrete, right? And then when you remove those formwork, then you get issues with your surfaces, right? So we need to make sure that we understand first the requirements, and then that our field operations also understand what do they need to do to achieve the finished surfaces that they're required to meet. Now, I bet many of you are going to laugh at the next one, because I assume that you guys have seen many things like that, but do we really need to get there, right? Did you say that we need reinforcement? What do you think, huh? What do you think? Do we need reinforcement? How are you considering this in placing your concrete, right? How is anybody even think about this and think that that's going to work and this is going to be just great? But this is the truth. This is the fact. This is how we build work. These are the things that you see in the field, right? And these are things as required by design. There's no contractor that is going to put more rebar than what they need to put, right? So this is really challenging efforts, right? How are we going to achieve a right consolidation process here and achieve a right product with a mix that is going to flow through all these, amount of rebar, and it's just going to be achieving the performance that they intend with the design, right? So, talking about that, obviously, we as contractors sometimes, we forget to really communicate the right ways of doing things. And this is something that I tell you from my experience, I tell you from the things that I get to see in the field, and I see a lot of what I call fishing with your vibrator, right? They throw it very far and then they fish with it. They bring it back without really following the right procedure, or understanding really what the vibrator do and how do we need to do it right, how to space it, how to size it, what is the sequence that we need to vibrate, right? So all those things are things that I'm going to share with you here in a couple of minutes with a brief case study that I'm going to show you. And this case is on a cap. This is a cap on a project that we're building in the East Coast, and this is a Kiwi project, and we were dealing with a lot of these ones. We're dealing with a lot of massive caps, and when you start looking at the surfaces, those surfaces look full of bog holes, and you start looking closer, and you can see they're more at the top, less at the bottom, and we'll talk about it. And then you don't see a lot of the little tiny bitty, bubbles. It's more of a larger size, coarse voids, indicative more of, efforts of vibration, right? So in that case, we went back to basics, right? We went back to basics. We look at the selection of the vibrator. We will look at the vibration plan. We look at the sequence, right? We engage people that could help us achieve the right process and sequence so we could teach our labor how to do it. And, like it says here, start vibration in the middle of the cap and work in both directions to move the air out. And then start from the bottom up, right? You need to move everything to the sides and then move it from the bottom up, right? So you can take all the bubbles out of those surfaces. Then obviously, from a plan view, you can see how obviously have a plan where you're going to insert those vibrators, right? And how you're going to finish and obviously bring all those bubbles that are towards the surface, bringing them up, in the edges and taking them out of the formed surfaces so you don't have those big chunk coarse bug holes. And things that we look at in that project too, and this was something that not too many people know about in the field, but was also the application of the film thickness of that form release agent, right? Sometimes you send somebody and they just put something, and they don't understand the effects of not applying correctly the form removal agent, right? So those are things that you need to consider, and these are things, taken from literature, right? These are things out there that you can use to communicate to your labor how to do it right. Thinking about surfaces and concrete and form surfaces, I cannot avoid talking about architectural concrete, and this is a project in Kiwi too, which, we were expected to come up with a product like this one. You can see here, very nice, smooth, color tones, pretty even, and something that will look like that, right? It's something that was the expectation of the client. However, this is a project where we did a lot of subcontracting in the concrete side, And then we got a subcontractor that was not really, too much into architectural concrete, and I think he learned the hard way. Let's put it that way, right? We ended up with a bunch of bug holes, form lines, discoloration stains, micro bubbles, and we did a lot of effort towards how we were placing, how we were conditioning the forms, and things improved a lot. However, something I'm going to talk to you is a little bit different to that. It's just a case where we were able to just look at not only the field operations and how we were preparing our surfaces or placing our concrete, but then what type of concrete we were using there to achieve that. So working with our partner in this JV, we were able to come up with a better option of material. And at that time, we looked at a self-consolidating mix, something that obviously is very common in the building industry. But in this case, we were not really expecting we had to go to an SCC case, but we ended up there. So just to show you an example, this will be the two different products that you would get and how you would compare one versus the other. From a high slope mix, you can see on the right side a lot of the bubbles and surface imperfections that you could get. Once we were able to tweak and refine the material to be an SCC working well, and obviously follow the best practices for preparation of the surfaces and all that, we were able to achieve a better product, more consistent in color and texture and things like that, right? So those are ways that, in the first case I talked about consolidation and a lot of preparation of surfaces. In this case I talk about that, but then also never forget that there's also material aspects that you can modify and improve the quality of your product. In hot weather, and we're going to talk now about four main things, hot weather protection, cold weather protection, thermal control planning, and curing. And I'm going to start with hot weather. In hot weather, there's something pretty basic, and I bet many of you are aware of what is a nomograph, right? And the nomograph I'm showing here is pretty basic. It's part of ACI 305, and you can see it also in ACI 308 documents for hot weather and curing. ACI 305 for hot weather, 308 for curing. And the basics of this is pretty simple. High temperatures, low relative humidity, and high wind speeds allow rapid evaporation of the surface of the concrete, right? So what does that mean? Rapid evaporation of the concrete surface. Well, if you get rapid evaporation, right, because you did not protect the concrete well, what's going to happen is you're going to get some type of plastic shrinkage cracking. And this is basically an example of one of the projects, and this is, unfortunately, is a case in our company where we had some, plastic shrinkage cracking. It's kind of by the book. You can see the series of short cracks, and then when you take a core, you can see the core has a crack that is limited to the top. It's wider at the top, and comes down to a very thin, tiny, and ends up near the surface. But things like that can be avoided by we as contractors implemented the right protection. Understand the mix, understand if it's the bleeding characteristics of the mix, understand how the mix performs, what are your weather conditions, if you have a windy placement, if you have a dry day placement, right? Are you going to put any efforts in operations to protect the concrete early age? Are you allowed to use an evaporation retardant? At what time you're going to come up and cure this concrete and make sure that the concrete is protected early, right? Think about those things and never have just one plan. In these cases, I would say always have plan B and plan C. Plan A most likely is not going to work. You have to move on and maybe install some windbreaks, right? Work on it, make sure that you are covered, right? Make sure that you're covered. The next one, in cold weather, I'm going to make this pretty simple, and I think this is the best way I found to communicate what cold weather means. Cold weather, and this is a slide that you will be surprised, this is a slide associated to safety in construction. And this is safety in cold weather exposure. Now, you don't have to be a concrete expert. You don't have to read all the documents from ACI to know this, right? If you really know how to prepare yourself and how to protect yourself in cold weather, believe me, you are 90% closer to get to know what cold weather means to concrete. Because it's not too different. It's not too different. You want to make sure some of the key things. You want to make sure that you understand how you're going to provide curing to this concrete, right? You're going to be able to, you want to know how you're going to protect the concrete from the cold, right? How you're going to insulate it. Do you need to provide layers of insulation? Do you need to provide any type of heaters, right? Then the other thing that is the most important thing for any person in concrete, and we're talking to concrete contractors, so we all should know this. You need to know your weather forecast. That's the key. Anything that associates to concrete construction, especially when you get into hot and cold weather, you need to know your weather forecast. And I'm going to show you an example later today that you're going to be, you're going to see exactly the effects of not knowing the weather forecast. But that's very important. It's not that complicated. If you know how to do it for yourself, it's really easy to implement it in concrete too. Then, mass concrete is a topic I cannot avoid talking. Is, in Kiwi we do huge amounts of massive placements, and I get involved in almost everything associated to mass concrete. And mass concrete is something that contractors sometimes have a tough time understanding and allowing that consideration, right? But thermal control planning for mass concrete is not a science project. If you think about it, thermal control planning is basically providing means to control temperature, providing means to reduce thermal shrinkage, and providing ways to minimize thermal cracking. And that's all that the mass concrete thermal control planning is going to do. It's going to be a tool for the contractor to consider what are the best strategies to protect the concrete from having different issues related to thermal. So when you have a thermal control place in hand, what are the things you're going to be looking at, right? You're going to be looking at the effects of mixture proportion on the constituents, and if you need to do some optimization with the mixes, right? What are the type of cycles you can achieve with that, right? Are you going to have some heat sinks? Are you going to have a formwork removal requirement that is going to be different than you expected because of thermal aspects? Are you gonna, you're gonna need some insulation? What type of insulation? How much insulation? How long do you need to keep the insulation? And the thermal insulation is different to your curing, okay? Then the maximum temperature bodies and temperature different bodies you're gonna achieve. The duration of thermal control, that's extremely important. How long do you need to keep thermal control and how you need to monitor it? And then obviously the ways that you're gonna use to either pre-cool or post-cool your concrete, right? You need to know that. Now, the other thing that we always have some type of a challenge, communicating and making sure that we implement it right in the field is curing, right? And curing, I always make it very, very clear. Curing is a verb. Curing is a verb. Curing doesn't happen just because you dump concrete and then concrete is going to do it itself. Curing requires an action. It requires an action. It requires an action to provide adequate moisture, adequate temperature, adequate time. And here I'm showing you 3 examples, water curing, moisture retention, and curing compounds, right? All of them are allowed by the, best practices in ACI standards and in the field and in what you typically see in specs. But know that curing is a verb. It requires we do something. We as concrete contractors need to do that, need to provide that, right? And if we neglect curing, we are not going to achieve the properties of the concrete that we're expecting, right? We're not going to get your durable concrete. You're not going to get the strong concrete. You may actually allow cracking to occur. So we need to be aware of those things, because then when things happen, things are going to come back to us as a contractor, right? So I'm going to talk now, my last section here is going to be lessons learned. And these are quick thoughts with images, so you can see that there is a lot of things that we need to take with us when we're doing this work. And I say it that way because I bet there's a lot of experienced people in the line that know and do a lot of concrete work, but there's always a need to kind of refresh your thoughts and refresh what we should know about concrete, right? What is the basic thing about a concrete placement? You need to know your concrete. You need to know what the concrete mix that's coming, right? What happened if you place the wrong mix? What happened? This is a keyword project. What happened if you don't place the concrete mix that is supposed to be there? You have to take it out. You have to take it out. And it happens. It happens. I bet many of you can have stories to share about that one. What about paying attention to details? And this is a project I work, before Kiewit as a consultant, and we work in the architectural concrete. But interestingly, this is a beautiful project, a lot of architectural details. And, you can see now a little bit of what I'm trying to go here. Pay attention to details. If you see the staircase there, you see that the top of the staircase look a little grayer than the rest of the concrete. And we're talking that was the last piece of white concrete in the building. What do you think happened there? The last set of placements in that concrete, what happened? Well, the concrete producer didn't pay attention to details, and they ended up with a little gray, concrete from the drum mixers in the trucks that were dirty because they didn't clean the trucks to use the white concrete. You can see it there. What about best practices? And I'm gonna, that one is kind of easy for many of you that are in the concrete construction in buildings, right? Steel trowel finish in air and train concrete. What is that? That's a no-no. Steel trowel finish in air and train concrete. That's a no-no, right? So obviously, things happen. And this is just an example. I'm showing it to you because this is an example that things happen. And the communication here is follow best practices. Just because you see a document that says that doesn't mean that somebody just came up with that and that's just, somebody that is crazy. Things happen, right? Make sure that you follow best practices because it's going to happen. What about check if it works or not? This is pretty simple. And this is actually one of our projects where we had a closure pour and we didn't verify that the mix, needed additional consolidation efforts. We were not prepared to do it right? So you can see that we thought that this was going to be a mix that would consolidate pretty nice and that would respond good to vibration, and there was a lot of rebar there. Well, we learned the hard way. We didn't check if it worked or not, and then we end up with a problem, right? What about this one? This one goes also in the same line of checking if it works or not. I bet you guys are trying to think about what is this? What is this photo I'm showing here? Match concrete to field operations. Well, I'm going to tell you what it is. We don't have time to really ask you questions right now in the process of me delivering the presentation. This is the result of a TREMI pour, a TREMI placement. A TREMI placement, you have the TREMI embedded underwater, and then you have concrete that is falling down either by pressure or gravity. And then obviously the concrete needs to be workable for a long period of time so it can continue to be placed. But then in this case, we did not really match the concrete to perform for the operations. So what happened? The concrete got hard. We were not able to complete the whole operation, the entire operation, and we ended up with a very nice tube and obviously a construction joint there, the cold joint that we then now have to prepare, and then now we need to do some rework, right? Just because we didn't do our work, preparing ourselves to get the right mix and behave and make it work. The same thing here, this is a very similar aspect of not really checking, what we were supposed to do. This is a project in the middle of nowhere in Canada where we had to pump 700 feet of sleek line of a mass concrete mix, and then somebody was smart enough to say that there's things called pumping aid, which are viscosity modifiers, and then obviously that if you use that, then you can improve the behavior of the mix under pumping conditions, and then obviously you're going to get a better product. Well, a lot of that concept and theory is true if you have the right mix and if you have the right operations that fit the mix, right? So what happened here is obviously we didn't have the right mix, we didn't have the right lubrication in the mix, and the type of operation we had for that mix was not right because this is a stop and go operation. You're not continuously flowing concrete. You're placing and stopping, placing and stopping, placing and stopping, and you have 700 feet of slick line with a lot of the viscosity modifier because somebody recommended that that would be a great pumping aid, right? Be careful with that. In this case, we're also talking a little bit here about TREMI, and this is an extensive amount of work I did in a project for a TREMI drill shaft operation, but the main concepts are this. Go back to basics and optimize your concrete. There's the first thing, make sure that you have the right aggregate structure, make sure that you understand what aggregate structure means for you. Do you need to have a certain blend, what you can achieve with the local materials, and make sure you optimize your aggregate structure, right? The other thing is on the bottom where you see the workability loss study. It's important in these TREMI mixes that we understand what type of workability demands we have in the construction operations, right? In this case, we wanted to achieve a spread of 15 after 12 hours, which can correlate like a 6 inches of slump after 12 hours. And as you can see, only one of the mixes really met that. And that was part of the development process. We needed to have that type of mix that could perform in that condition. We were able to achieve it. So what I mean is make sure that you have the right testing program to verify the mix works and optimize the concrete for that. The next one here is interesting because this one is actually the result of a poor specification. This is a specification that calls for a very low slump in silica fume concrete, and as you know, when you're dealing with silica fume concrete, one of the main issues, you need to allow more dispersion. You need to allow dispersion of all the fines. So here you're dealing with only 5 inches of slump, and sometimes, they were not allowed more than 5, and you would get basically, that type of issue, a very sticky mix that would not finish well. But then the issues come up and start reflecting in the structure on the sides, where you have a lot of bug holes, because the bug holes, the air was not really being able to get out of the structure, and it was being trapped on the top. The next one is the one that I'm telling you, that know the weather forecast, and this is a very, very, very controversial case that we have, where we allow the concrete to freeze. And as you can see, that goes again back to the basics, right? If you know your weather forecast and you protect the concrete properly, you're not going to get into these issues. And it is true, concrete is going to freeze if you allow it to freeze, right? So here you have some photos that you can see the crystal growth and on the top of the surfaces, and then on the sidelines we allowed also, because of the issues with that, we allowed some settlement of the concrete over the rebar, and settlement cracking showed up too. We had to remove and replace the entire slab that we allowed to froze. You don't want to go through that, so make sure that you know your weather forecast. And then here, I'm going to make it pretty cool and simple. Be aware of what could happen to you. Talking about settlement cracking, I'll ask you this question. Can you see the snow melt system here? If you look at pretty closely and you look at the cracks, you can see that they have a pattern. So this was an issue of a settlement cracking. We had a snow melt over the rebar. It was too close to the surface. The mix that we used allowed, some settlement and bleeding. And therefore what happened, we got a bunch of reflective cracking on the top. So you could see actually the snow melt system on the left side. You can see even the curve. So that was the case of reflective, settlement cracking issues. And then, I'm just going to close with one slide. So there's only one more slide, and then we open for questions and comments. I just want to share with you a lot of this discussion that I've had, and main takeaways from 15 years in practice is basically pretty simple. We as concrete contractors need to know the specs. We need to promote early involvement. We need to know and follow best practices. And there's several things that I'm always very, very, I think they're very important. Communicate the facts. There's no reason to hide the facts, right? You deal with them, you present them, you look for solutions. Be prepared to adjust and understand construction demands. We as builders, we need to understand what construction demand means to the operation, what does it mean to the materials we're going to select, right? Technical capable resources, and use economical choices, not cheap ones. I went through that already. The economics of mix designs is not selecting the cheapest one, the lowest cost. Low cost of operations means something more than just the unit price of the mix. Optimize and innovate with a purpose. There's a lot of things that you can innovate and get crazy and creative, but innovate and optimize with a purpose. Just because we have SCC in the markets, it doesn't mean that you're going to go and use SCC everywhere. Just because you have viscosity modifiers doesn't mean that you're going to go and use them everywhere, right? There's a purpose for it. There's a purpose and a location for that. Meet requirements, exceed expectations. It's all about the client. Pursue constructability and performance. Is forget about what you did maybe in another project with the same case. Think about what you're dealing with today, what is constructable, and what you can make it work and perform in the field with the materials you got. Think about success as a team. It doesn't matter if you're a general contractor, a subcontractor, a concrete producer, you're part of the client. The truth is that we all work for one thing, for the project, for the success of a team, for the success of the client, right? So think about it that way, and then add value to the project. It's pretty easy to add value, and the whole thing is just about making sure the project is successful. And if we need to get help, make sure that you get the right help. So with that, thank you very much for the opportunity, and then we can open the line for questions and comments.
Thank you. We will now begin the question and answer session. If you have a question, please press star, then 1 on your touch-tone phone. If you are on a speakerphone, please pick up the handset first before pressing the numbers. Standing by for questions. And at this time, we have no audio questions at this time. Oh, and pardon me, it does look like we have a question from Dennis Evans. Dennis, your
Yeah.
line is open.
Yeah, Denise
Or-
Evans, Reliable Concrete Accessories. Thank you. That was a very informative webinar. Appreciate it, Oscar. I am wondering about the curing aspects. We didn't go over too much about it, but I'm wondering about the strength value on curing. Like, what, in your experience of the 15 years in the business, what products and what, or not, not naming names, but what types of curing provide the best strength cure for structural concrete and for mass concrete and just any kind of large concrete project?
Yeah, well, curing, the curing aspect is all about also the application and exposure. For example, what are you trying to achieve with curing? Is basically avoid the concrete, getting rapid drying from the surface. In the case, for example, if you're dealing with a pavement or a bridge deck that is going to be exposed to a lot of the de-icing chemicals in the north part of the U.S., right? Then obviously you're going to want to have some additional water being applied on the surface, right? Because you want to make sure that material receives proper hydration and hydrates pretty well on the top of the surface, right? But for example, when you're dealing with things that you're dealing a little more like, okay, this is going to be a concrete that is going to be, it's not going to be exposed to critical conditions like the icing chemical, right? But you just want to get, some level of protection from the material drying too fast. Then obviously you start looking at other options like moisture retention and obviously curing compounds can be used in some cases. For a strength purpose or not, we're talking, the curing all is going to be affecting the very, very skin, right? So if you think about it, the skin of the surface is the one that's going to be mainly affected by the curing. However, you think about providing some level of protection from rapid evaporation because then that's going to allow rapid drying shrinkage cracking too, right? So it's all about the application, the exposure, the conditions, and then what type of operations are also coming through that are going to affect the process that you're going to implement, because all of them can provide you a good product. I don't want to pick on one or the other. That's my point. I don't want to pick like this is best, this is not good, right? All of them have a place, and all of them are going to allow you to get good concrete. It's just making sure that you understand what's going to be the purpose of the use of the structure and that you understand the exposure. And that's going to allow you to then get a better selection on what to pick for a curing method.
Okay. All right. Yeah, I think that answers it. I look through specifications all day on curing, and I see a lot of different specifications, and sometimes contractors have choices between a curing compound or a wet curing blanket or a plastic covering or multi-use. So as I'm learning the business, I'm just wondering, how the choices are made. And so you're telling me that it's according to what conditions the concrete's going to be under, whether it's outside, indoors, or maybe large.
Yeah, well, that's one aspect of it, right? In many cases, especially in curing, sometimes we don't have really the option, right? And there's something that is directed by a certain spec or client, and they just want to do something.
Right.
But so in that case, obviously it's different. But in the other cases, like for example, when you're talking about mass concrete, I'm going to pick that one because we do a lot of it.
Sure.
You need to be careful then because, for example, people say, well, you need to water cure certain mass concrete. Well, it depends what type of mass concrete. Traditional old mass concrete where you would do a lot of lean mixes that do not generate a lot of heat, sure, you can allow water curing in that case. That's the way that the Corps of Engineers, Bureau of Reclamation would do the things, 20, 30, 50 years ago. Today's structural mass concrete, is different. You have mixes that are really required to meet 5,000, 6,000,
right.
psi that generate a lot of heat. Now, if you start coming and bringing some water curing on top of those surfaces, you can then induce thermal gradients because you're allowing the surface to cool down pretty quick while the concrete in the core is not. So then you need to be careful, right, which application you're using what. And in some cases, for example, curing compounds can be pretty pretty handy. You know, they can be really helpful, but then sometimes you need to recognize too that the curing compounds are not 100%, impermeable. You know, you're gonna allow
Right.
some breath. They breathe, and then the problem with curing compounds sometimes is that we go to the field and then we give the whole thing to somebody that doesn't know how to apply it, and then they don't know how to apply it, right? So then
Right.
you have then conditions that you say, okay, you're gonna put a curing compound, and then you need to come on top and put water curing, right? Like sometimes in bridge decks, that's the way they do it in New York. They tell us you have to go curing compound. That will be the first step you're gonna do, and then after that, you're gonna go and implement 7 days of water curing. However,
Right.
when you go, for example, in and you're doing some type of a column, let's say I'm going to use a column as an example, and you have forms, you may just let the forms stay in place, and the forms stay in place for X amount of time, let's say 3, 4, 5 days, and then that allows the material to not lose a lot of the moisture pretty quickly, and it makes it work, and you get the strength pretty quickly, and that's it, you move on. Typically, for strength, what the industry commonly uses is a 70% of your design strength. So, and that's typically something that I will be in the 5 to 7 day range.
Right. Right. That's what I was kind of. I mean, I've heard that. I'm just learning, so I'm just taking notes here. So you said 70% of what? I missed that. What did you say?
Yeah, if you go to ACI 308, ACI 308R talks about, the different considerations for curing. I think that's the best practice that I can make reference to.
Okay.
And if you go through it, and you can see different aspects about curing, you can see the aspects about early curing, which is going to be more on the protection, and then you get into the different as intermediate curing and final curing, and what are the methods and the reasoning behind it. I think that will be the best document that you can look at.
Thank you. I have that one, and I will take a look at it. That's good advice.
Yeah.
Thank you. That was very helpful.
Sure.
We have no further audio questions at this time. Oscar, do you have any final remarks?
No. If there's no more question, I appreciate the time. I enjoyed presenting this to you, although I couldn't see you guys. So I hope everybody learns something about it. And if they want to reach out to me directly or have any questions, I'll let you know my email, concrete@kiewit.com, concrete@kiewit.com. So feel free to send me any messages. If not, contact directly ASTC, and they'll for sure reach out to me if you guys have any questions or comments.
Thank you, ladies and gentlemen. This concludes today's conference. Thank you for participating. You may now disconnect.